Alright, today's lesson is 5-10, and we're transforming linear functions. We've got several different objectives today. We want to recognize families of functions, describe translations between functions, describe rotations between functions, describe reflections between functions, and then describe multiple transformations and consider real-world problems. We're going to go back for just a second and review a little bit. It says a family of functions is a set of functions whose graph have basic characteristics in common. You've learned about the parent functions in previous lessons, and you do not have to write anything on this slide down. All linear functions form a family because all their graphs have the same basic shape. All linear functions form a line of some sort. It may be a line up here, it may be a line down there, maybe a line in the middle, but they all form a line. Alright, today we're going to consider three types of transformations of linear functions, and you need to write these down. Transformations are as follows. There's a translation, which means the slopes are the same and the y-intercepts are different. So understand that in a translation, the slopes are the same, and the y-intercepts, or the b, so the slopes are the m here, and the y-intercept, or the b, is different between the two functions. All right? Now you have a rotation, and you do need to write all of this down. You have a rotation, which will always be about the y-intercept, and in a rotation, the slopes are different, and the y-intercepts, the slopes, or the m's, are different, and the y-intercepts, or the b's, are the same. So it's exactly the opposite of a translation where the m's are the same and the intercepts are different. The third and last kind we're going to look at today is going to be the reflection across the y-axis. A reflection across the y-axis means the slopes, or the m's, are opposite. So they're not just different, but they're completely opposite, meaning one is positive, the other is negative. And the y-intercepts, or the b, are the same. Make sure you have all of that down before you move on. You can pause the video now if you need to. So that's our first objective, is recognizing families of functions. And now we're going to describe translations between functions. Number one, I want you to kind of ignore what's over here on the graph for starters. So you're ignoring this. It says this is a graph of the function f of x equals negative 2 and g of x equals I said that wrong. This is a graph of f of x equals 2x and g of x equals 2x minus 6. Describe the transformation from the graph of f of x to g of x. So I want you to look at these two functions over here, and basically, if you can't already tell, it's in bright red and bright green for you. I want you to recognize the difference between these two functions. You can see right here that they both start with 2x, and then you have plus 0 and negative 6. So I want you to think of this as like a hidden picture where you're trying to find the difference between the two functions. The difference here is that this one has a b of 0 and this one has a b of negative 6, or a begin, or a y-intercept. So looking back at those definitions that we just wrote, you should be able to see that when my slopes are the same and my y-intercepts are different, it's a translation. I call this a translation. It's the reason you have the word slide here is because it slides down the y-axis. So it goes from here to here, as you can see in the graph. But even without a graph, I want you to be able to recognize it given the function. So it says it translates down 6 units because it goes from 0 to negative 6. It goes down 6 units. So this is my original line right here, and it translates to this line when I change my b. So make sure you have down what's in the box here. You don't have to write this graph, just what's in the box on all of these problems. You're writing what's in the box. Number 2 says this is a graph f of x equals x plus 4 and g of x equals x minus 2. So again, in bright red and green here, you can see the two differences between the two functions. I have positive 4 here for my b and negative 2 here for my b. That is a difference from 4 to negative 2, a difference of 6. So that means that my line is going to translate down 6 units. So you need to write what's in the box. This is a translation, and my line goes down 6 units. Number 3 says this is a graph f of x equals negative 3x minus 1 and g of x equals negative 3x plus 2. So my m on both of these is negative 3. Negative 3, that's my slope. So my slope is not changing, but again in bright red and bright green I can see here that my slope, my b, or my begin, my y-intercept, goes from negative 1 to 2. That's a difference of 3. So if I look over here on my graph, I can see that it's going up 1, 2, 3. So this translates up 3. Make sure you have that down. Translation, up 3 units. Number 4. This is a graph of f of x equals negative 1/2 x minus 4 and g of x equals negative 1/2 x plus 3. You can see here that the difference between our negative 4 and 3 is 7 units. 7 units, so it translates up 7 units. Make sure that you have that down. That's it for describing translations between families of function. That's pretty simple. Next, we're going to look at describing rotations between functions.
Okay, a rotation is what's called a turn. And this says, number 5, this is a graph f of x equals x, g of x equals 5x. Describe the transformation from the graph f of x to the graph g of x. So go ahead for number 5 and write down your two functions, f of x equals 1x plus 0 and g of x equals 5x plus 0. Looking at this, we want to look and say, okay, what's the same here and what's different? Here, our slopes are different. The number in front of the x is different. Our y-intercepts are the same, but our slopes are different. So that tells us that this is a rotation. So we know that it's going to be a rotation. And we need to tell what point it's rotating around. Here's a graph of the two lines. And basically, again, you can kind of see this arrow here. It's actually rotating the line. And it's rotating around the y-intercept here. So I want you to write that it's a rotation. And it's about basically saying what point is it rotating around. And it's always going to be your y-intercept. So this point, or this number is always going to be 0. And this number is always going to be your y-intercept. And in this case, your y-intercept right here is 0. So it's around or about 0, 0. The last part we're going to write is whether it's more or less steep. So we're going to look back at the slopes. This slope tells me that I go up 1 and over 1. And g of x is 5, so it tells me I go up 5 and over 1. And you can see this with the graph. The f of x is going up 1 over 1. And then g of x is going up 5 over 1. So we're going to look, g of x is much steeper than f of x. Because it's going up more and over less. So it is steeper. So your answer for number 5 is it's a rotation, about 0, 0, and it is steeper. Take a minute, make sure you have everything in the box copied before you move on. All right, number 6, go ahead and write this one down. F of x equals 3x minus 1. G of x equals 1/2 x minus 1. Again, I know that this is a rotation because of the fact that the slopes are different. My slopes are different. That tells me that it's a rotation. So we're going to write the word rotation for it. And then we want to know what point is it rotating around? What point is it turning around? So if we look at this graph right here, we've got our f of x line in red and our g of x line in green. And it's rotating or turning around this point right here. And again, this is always your y-intercept. So for us, That's going to be the point 0, negative 1. So rotation, because the slopes are different, it's going to rotate around, and again, your x value is always going to be 0 if it's a y-intercept. And then you're going to look at this n number right here. This is a negative 1, so it's rotating about 0, negative 1. And then we also want to know more or less steep. So we're going to look at it. F of x is going up 3 and over 1. G of x is going up 1 and over 2. So the line f of x is much steeper than g of x. So g of x is less steep than f of x. So we're going to write that this one is less steep. So those are the 3 pieces of information that we need for rotations. The fact that it is a rotation, what point it's rotating around, and whether or not it's more or less steep. All right, so again, make sure you have all that written before you move on. All right, number 7, go ahead and write these 2 functions down. We have function f of x is 1x plus 2. Function g of x is negative 2 over 3x plus 2. And again, we know that this is a rotation because our slopes are different and our y-intercepts are the same. So that's what tells us that it's a rotation. Our slopes are different here. So we know that it's going to be a rotation, so that's the first thing we're going to put for it. So we're going to write rotation. Then we want to know what point is it rotating around, what point is it turning around. So you can kind of see again from the graph here, you won't always be given a graph, but it's right here is the point that it's turning around, because it's going from here and it's rotating around to this line right here. So it's rotating around this point right here, and that's your y-intercept point. So again, when you go to write that, it's always 0 for your x, because it's a y-intercept. And it's always your b, or your y-intercept, right here. So it's 0 and 2. You can kind of see on the graph here that that's at the point 0, 2. But again, you don't need the graph. You just need to look right here. It's 0 and the end number for the rotation point. And then we want to know if f of x, or if g of x is more or less steep than f of x. So if I look at f of x, it's going up 1 and over 1. If I look at g of x, it's going down 2 and over 3. Now, it doesn't matter that it's going down. Steepness doesn't matter whether it's positive or negative. It can be going down more steeply than it's going up. We just want to know if that line is steeper or less steep than the other one. So here, it would be more steep to go up 1 and over 1 than to go down 2 and over 3. All right, so again, rotation about 0, 2, we already wrote that, and it is less steep. And it's not less steep, again, because it's negative. It's less steep because going down 2 and over 3 is less steep than going up 1 and over 1. So make sure you have rotation about 0, 2, and less steep written down before you move on. All right, number 8. Go ahead and write your 2 functions down. We have f of x equals 4x plus 1 and g of x equals 2x plus 1. Again, just like I've said with all the other rotations, I know that it's a rotation because I'm going to look right here and the number in front of the x is different. So my slopes are different, which tells me that it's a rotation. So I'm going to write rotation. Then we want to know what point it's rotating around. And again, without even looking at the graph over there, I know it's rotating around 0, 1 because of the end number right here. I know that my x is always 0 for a y-intercept, and it's always the end number right here. So 0, 1 is the point that it's rotating about, because it's rotating about the y-intercept. Now we want to look at more or less steep. So again, without even looking at the graph, I know that f of x goes up 4 and over 1, and g of x goes up 2 and over 1. So going up 4 and over 1 is more steep than going up 2 and over 1. So g of x is less steep. It is less steep because going up 2 and over 1 is less steep than going up 4 and over 1. Make sure you have all that written before you move on. So you should have rotation about 0, 1 and less steep written there. Alright, so that's describe rotations between functions. Now we're going to look at describing reflections between functions.
Okay, so now we're going to describe reflections between functions. This is a graph of f of x equals 2/3 x plus 2, and g of x equals negative 2/3 x plus 2. So again, we're just looking for the difference between the two functions. Here you can see that I have a positive 2/3 as my slope, or my m. Here you can see that I have a negative 2/3 as my slope, or my m. My y-intercept, or my b, is the same. It's positive 2 on both functions here. So what this means is that I simply have a reflection. My graph flips. It's a mirror image across the y-axis. If I were to take a piece of paper and fold it in half right here on the y-axis, it would reflect the same image on each side. It's a mirror image. I'm sorry, if I were to fold it. Okay, I said that right. I just questioned myself. Sorry. All right. So there's a reflection across the y-axis, and in this case, it's always going to be across the y-axis. So again, you're just writing what's in the box over here, and you're recognizing that your slopes are opposite. You have positive 2/3 and negative 2/3. Get all that down before you move on. All right. So here I have a graph of f of x equals 2x and 2x plus 2, and g of x equals negative 2x plus 2. So my slope, again, is the opposite. Here it is positive 2, and here it is negative 2. Positive 2 and negative 2, and that means that there's a reflection across the y-axis. And again, this blue line just means that if I were to fold it, it would look exactly the same. This side of the graph is a mirror image of this side of the graph. Make sure you have down what's in the box before you move on. All right, number 11 says this is a graph of f of x equals 1x plus 0, and g of x equals negative 1x plus 0. So again, I can see that my slopes, or my m's, are what's different here. I have a positive m here, positive 1 for my m here, and a negative 1 for my m here. So it is, again, if I were to fold my paper across the y-axis, I have a reflection. It is identical on this side as it is on that side. It's a mirror image. So it is a reflection, and again, I need to write across the y-axis. So make sure that you have all that down before you move on. Number 12, f of x equals negative 3x minus 1, and g of x equals positive 3x minus 1. Again, my slopes are just the opposite. I have a negative 3 here and a positive 3 here. So again, my b does not change, or my y-intercept does not change. It is a reflection across the y-axis. If I were to fold my paper, it would look like a mirror image from here to here. Make sure you have down everything that's in the box before you move on. All right, and it's as simple as that. We've described reflections between functions, and now we're going to describe multiple transformations and consider real-world problems.
All right, this is number 13. Go ahead and write down your functions. F of x equals 1x plus 0, and g of x equals 2x minus 3. There are multiple transformations going on here because notice that my slopes are different. So that tells me that it's going to be a rotation. Also, my y-intercepts are different, so that tells me that it's going to be a translation. So two different things going on here. The slopes being different tell me rotation. The y-intercepts being different tell me translation. So we're going to say rotation about 0, 0. We're going to use the initial y-intercept right here, the 0, 0, for our about. So it's showing us that f of x right here is turning our rotation right here. And then from here, it's going to go down 3 units to get to the g of x here. So again, it also tells us there's a translation. It's going from 0 to -3, so it's going down 3 units. So you need to have rotation about 0, 0, and translation down 3 units for that one. Make sure you have everything in the box written before you move on. All right, number 14, go ahead and write down your functions. F of x equals 1x plus 0 and g of x equals -1x plus 2. So we're going to look at the two functions and say, okay, what's going on? First thing I notice is that my y-intercepts are different. That tells me that it's a translation. Then if I look at my slopes, they're the same, but one is positive and one is negative. That tells me that it's going to be a reflection. If our slopes are the same, but one's positive and one's negative here, then that tells me reflection. And for us, reflection is always across the y-axis. Then if I look at the two end numbers, that tells me that I'm going to have a translation because my y-intercepts are different. So, and it's going to go from 0 to +2, so it's going up 2 units. So please make sure that you have the word reflection across the y-axis and translation up 2 units written on your paper. Now I want to go over to the graph. Here's our graph of f of x, and if we reflect it across the y-axis, in other words, making our slope negative, we get this new blue line right here. Okay, and then if we take that blue line and we translate it up 2 units or move it up or slide it up 2 units, we end up on this green g of x line right here. And that's what transformations are doing. They're moving one line to get to the other line. So again, if we take the f of x and we translate, or if we reflect it across here and then we move it up to, we end up on the g of x function line. Again, take a minute, make sure you have what's in the box written before you move on. Alright, the last two examples are real world examples, so we are going to save those for class tomorrow. But now we should be able to describe multiple transformations. And again, we're going to consider the real world problems in class tomorrow. So this is the end of your video. Thank you for watching.